Okay guys, hello guys. So today's class is for a relation between electric field and electric potential. So here we are going to relate electric field with the electric potential now. So how can I do this one? By taking a source charge and the point charge which is taken from the infinity distance to the finite distance. So simply now you take a simple charge which is, you can take a source as a positive charge. So you can take a positive charge which is Q here. So around this one definitely will have its own field. So now what you are doing is, I wanted to bring a point charge to this field. So here the point charge which is located at an infinite distance. So now from there I am bringing it to a finite distance which is at M. I am bringing here to the point M. I am bringing here. Now from this particular point M2 it is coming to N. From the finite distance only I am going here. So this N point which is located from here to here, it is located at the X distance. And whenever it brought from M to N, it is just a small displacement I made, which is I can write as dx. I have direction for the distance, so I can tell it as a displacement. You know, when I am doing it, I am applying some external force. Now what could be the external force on this one? So thus that I am doing a external force, I am applying external force to displace it, then definitely what can I have here? A external work also there. So that I am writing here. So some external work did from M to N, you see. So external work dW is equal to, what can I write here? Simply F external dot dx bar. Dx bar is a displacement. Okay. Now you see here, you know, work done means force into displacement. Force I got and displacement. What could be the force here? Force is here. It is overcoming the. It's because this is also positive charge, and this is a test positive charge also positive charge. It is overcome whenever I am bringing into that its field. Definitely I should overcome its repulsion force. So I am taking it. So repulsion force, and now you see from here to here if I join here. So you know here its electric field is acts outwards, and its repulsion force is also in this direction only. As ever, whatever the electric field intensity direction is there, same direction force direction is also there. So that is why I am writing here force direction also in this direction. So now here the force here F external means it is opposite to it, right? So I can write F external force is nothing but negative F. Here dx bar, if I take its what can I take its magnitude, then I can take dx bar, I can write dx. Then if I substitute this thing in this equation, what can I write? dw is equal to minus f bar. You no need to write because I am taking its magnitude only, minus f only. Why it is coming f negative means whenever it is brought, I have to apply force which is equal and opposite to this particular repulsion force. That is why I am taking the negative direction. Minus f into dx. Okay, you know already F means, what is F means? F is nothing but electric field into a point charge Q0. If I substitute here, what I will get here? So now net external field is equal to, what can I write? Net external force applied is here how much? dW2 from M to N, how much? dW is equal to, what can I write here? Minus EQ0 into dx. Please take the notes. If you want to take the notes, what you have to do is you have to fuse the video and you can take the notes. So now take down the notes. So from this equation only I am going to make a next step here. So from that equation only I am going to make a next step here. So see, take down the notes here. Okay. So now simply I am not removing this equation. This diagram, I am going to remove this side. So if I remove this side, what I will get is, so if I take this equation, the box wala equation, this equation, if I take it, then what I can write here, dW is equal to dW divided by Q0 is equal to, what can I write? Minus E into dx. Okay, E into dx. Now simply you see, work done, external work done on the test positive charge is nothing but, what can I write here? It's a potential difference dV. Here I am doing a small work, so you will get a small potential difference. So you see here, the small potential difference, now we have a relation. E is equal to, if I just write in terms of this potential difference, E is equal to, what can I write? Minus dV divided by dx. This is we are doing, so we are getting, this is nothing but you are getting the relation in terms of what? Electric field and electric potential, and it is in the direction of which direction? Which is in direction of, what is this? The electric field direction is, what is here? Positive x direction. So in a positive x direction, what is the relation I can write here? In a positive x direction, you can write a relation here. Simply you can write a relation. In a positive x direction, what a relation I can get? E is equal to nothing but, if it is moving in this direction, I can take Ex. Electric field in a x direction, I can take Ex also. So Ex is equal to, I can write minus dV divided by dx. It means dV divided by dx is nothing but a potential gradient, you can say, because it is in a positive x direction. If I write it in a y direction, Ay is equal to minus dV divided by dy. Okay, simply you can write in z direction also. Ez is equal to, what can I write? Dz divided by dV divided by dz. If it is only in the x, if it is having only x direction, I can use partial difference also here. So which is minus dou v divided by dou x, or else minus here in y direction dou v divided by dou y, in the similar direction minus dou v divided by dou z. Guys, you can fuse the video and you can take down the notes. So this is your relation. This is nothing but your relation between, what is our topic here? Relation between electric field and electric potential. Thank you all. And if you like my channel, subscribe it and comment on it. Thank you.